friends, we are going to see more practical examples of closer look at methods and classes. The next example we are going to see that is of argument passing. For that we are going to create one project. Call by value. New package. Call by value. Now that we create one project in one class that is called as call by value main function. For this, we create one test class of J I into is equal to 2. That means I is equal to I into 2. J divided by equal to 2. That means J is equal to J divided by 2. Now, OB is equal to new test. This is the object of class test. Then int A is equal to 15. B is equal to 20. And initializing. Print A and B before calling. Before calling. Plus space A. A comma B. A and B of calling. And B before call 15 and 2. After call 15 and 2. Why? Because this is called as call by value. Now let's modify this sum. Let's modify this code. Print I equal to I plus and J plus J and equal to and J. Now I run this code and J. Actually in method math modification is going or modification is getting performed, but since this is called by value, actual value remains intact. Now we will see call by reference, that is passing object as a parameter. See the difference. I will close this project. Sorry. all by a plus 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 function. Also, it will be one last list that two variables need a comma b and best entire comma b. A is equal to I, B is equal to J. While method as object. Now I will modify A and B through object O dot A into is equal to 2 O dot B divided equal to 2. This will be new test. Now O dot A and O dot B before all plus dot A plus O dot and O dot A dot as object as a parameter. O dot A and O dot B all. Two values are changed. I also do here one thing. Parameter O object dot A and object dot B is equal to O dot B. Equal to score in method also changes are taking place, and after call also changes are taking place. Why? Because we are calling by reference. This method is called by, we are passing object as a parameter. Now we will see the example of returning objects. All the examples are already explained in the theory part. Practical, we are going to see the actual result so that you will understand it better. You have the complete explanation of theory part. You can view the theory videos. Package for return class and also I create one test class as test unit A test 2 I A A A is equal to I, which is a parameterized constructor of test class. Then increment by 10. And increment by 10. So this method is returning the test class object because return type is test. Now I create test m is equal to new test a plus 10. What is it doing? What is it doing? It is creating object of class test, that is 10, and after that it's passing parameter by incrementing 10. So a will be initialized. A, whatever the value of a will be incremented by 10. So first of all, we will create an object so that you will understand. Test one is equal to new test 2. So first value is 2, then test 2. Now whatever the value is returned by this method, it is saved here in object 2 is equal to object 1 dot increment by 10. What does increment by 10 will do? First of all, a is initialized to 2 here in parameters constructor. A is equal to 2. Then when I call this method increment by 10, so a will be incremented by 10. So 2 will be incremented by 10 and this 2 will be written as 12. And now I can print it. One dot a plus dot a plus is equal to so in Obito, already told you implemented by 10, which value is 12, and again I implemented by 10, so what is the output? 22. Jump to 2, 12, and 22. This is an example for recursion. Is for class culture written inside this. Have complete static world name. So this recursive function is a basic example we are going to see, which is called as factorial. So we are implementing factorial class. Int factor. Int n. If n is equal to 1, return 1 result. Factor. Yes, return 1 else I will return the result. Now I will create output of this factorial class. Factor dot factorial of 5. Without of recursion, the function is calling itself. And this is the stopping condition, which is very much important. You should not forget this, otherwise your method call will go into infinite loop. So you have to remember these things. So one more example we are going to see, print array values, as we have seen in theory part. 'Cause I create new class called as recursion 2. Class recursive test, and that arrays of values. Test integer I, parameterize constructor values new int of I. Void int array 0 return else int array of I minus 1. Out of println bracket 1. Thus, now I create the object of this class in main function. Continue. Continue test object new continue test for that values. Int I for int I is equal to 0, I less than 1, I plus ob dot values of I is equal to I and ob dot print array for 10. So here what I did, for 10 number of times, each and every position I put the values from 0 to 9, and in print array these values will be printed using recursion. Now I run this code. You can see the output. from 0 to 9, all values are displayed one after another using recursive method. Now we see the access controls example. Control. Create one example class text. Is by default public, then public entity public. What is different between this public and this public? This public is accessible to all the classes that are available in the same package, and public by only public it is accessible throughout the program. It is public access and private int C. You can operate upon this using getter and setter. Void set C. Initially, void set C int I. Is equal to I. Now we can generate the getters and setters method. Right click, select the variable, right click, and then go to source and create generate getters and setters for variable C, which is private, and click on generate. Okay. This public is given by them, and automatically this creates these two methods. So you don't have to write each and every private variables, getters and setter methods. Now you can remove this public, it is by default public, or you can keep it as it is. It depends upon you. Now I create object of class test. New test. Dot area is equal to 10. Equal to 20. Okay, so these two can be accessed directly because these are public. I can now access the C. Let's see what happens. then it will give me error change visibility of C2 package. Test.c is not visible because it is private. Now I try to assign value 100 to it. So replace ob.c fixator or change visibility of C2 package. So two fixes are available over here. Why? Because C is written as private. I cannot access it directly. So how to access it now? You have to access it using status and status. How to write it? Object.setC as 100. And print the three values. Set C. C is capital here. Now I print them A, B, and C. A, B, and C. Dot A plus space dot B plus space dot C. I cannot write it like this. I have tried ob dot get C. That will display the value of ob dot C. Now I will run this code as usual and we will see the result. A, B, and C are 10, 20, and 100. So this way we have understood the access modifiers. We will see one more example for access modifier. That is stack example we have seen in the previous session. Now we will see in detail in practical. I create one project whose name is test stack Dave. Now I create package for extracting or test stack. Okay, now I create a class called test stack main. Test stack public static void main. Now create class stack for actual operations push and pop. Here one array private int stack is equal to new int of 10. Private int top of stack. Why we have made this to as private? To prevent the malicious access to top of stack and stack array. If the stack will go in wrong hands, they can harm the stack class. So for that purpose, I made it both private. Now top of stack is equal to -1. Next, push item void push int item. These two are same push and pop as previous. If top of stack is equal to 9, stack overflow stack overflow or stack is full. Else I put stack top of stack plus top of stack is equal to integer item. Then message push. Then int pop. Int top of stack is equal to all is less than 0. Then stack underflow. Print stack underflow. Stack underflow and return 0. Else return stack return stack top of stack minus minus. The difference between this plus top of stack and top of stack minus minus I have explained already in the theory part. What is the difference? Here, first of all, top of stack is incremented, then item is put onto that top of stack, and here, first of all, top of stack is popped out of stack, top of stack item is popped out of stack, and then it is decremented by 1. Okay. So now, test stack public static void main. Stack will be created stack my stack 1 is equal to new stack. Stack my stack is equal to new stack. Numbers on the stack for I is equal to 0, I is then n, I plus plus my stack 1 dot push I. Then for int I is equal to 10, I less than 20, I plus plus my stack 2 dot push I. Next, of those items of the stack of those items of the stack. Stack my stack 1. Iterate 10 times for int I is equal to 0, I less than 10, I plus plus. I pop existing dot out dot println my stack 1 dot pop. Then stack in my stack 2 10 times I will iterate, and then now I try to modify my 2 stacks directly. My stack 1 dot top of stack is equal to -2. Cannot modify like this because top of stack is not visible, it is private. This is also not valid, and my stack and comment species so that you will understand it. My stack 2 dot stack of 3 is equal to 100. It is also not valid because it is not visible. So nobody can accidentally or maliciously change your code or any data name. Now we will run this code. All atoms are displayed stack in my stack 1, 9 to 0. They have put from 0 to 9, and by popping they have displayed in 9 to 0. And in stack 2 they have put in 10 to 19 manner, and by popping they are popped out of the reverse order. Now understand static example we will see and improve this project. The new Java project. Needs static pane. Then here new package for new static. Then new class new static. Now equal to 3 static int b is equal to, so static void method that handles the static data index x is equal to plus x is a small x, then a is equal to I. Okay. A is equal to plus a, and b is equal to plus b. Block initialize separate static block that have b is equal to a into 4. Static method can be called without use of object, so directly method 42. So first of all, when the execution begins, Before any object is created, static in A is initialized to 3, B is not initialized. Then in static block here, B is initialized to 3 into 4, that is 42. And while calling main, X is initialized to 42. Now we run this code. Now we will see the example where you can call the static members in a separate class in which they are not declared by use of class name dot method name, class name dot variable name. Okay, for that we will see one more example of static. Close this, new static by name name. Class static by name. Then I create class static table static table is equal to 42. Static is equal to 99. Static void call new that handles the static data, and A is equal to plus A. Now you can see the variables we declared as static are written in italic. Normal variable is A and static variable is in italic. You can see here, we will see. This C is normal, but this A and this B are written in italic way. Okay, in that bold, italic, and underline. Now, static demo dot class name dot method name and class name dot variable name B is equal to plus static demo dot B. Now I will run this code. B is equal to 52, which is written here. We will call me class name dot method name, and B is equal to 99, which is accessed directly static demo dot B. Now the second part of practical is finished. In the remaining part, we will cover the remaining examples. So meet you in the next session. Thank you so much.